Well, there weren't supposed to be two parts for this, but unfortunately something happened during the middle of the video, so you'll have a part one and a part two. So let's go back to part one, where we were just talking about, I was talking about some basic ideas of solving systems using a matrix. And so the first thing I want to talk about, a few things we talked about last time in 5.7, is remember the idea of having rows. Remember, rows go across. You also have columns, and columns go up and down. It's really important that you know which one is which, because when you're solving with a matrix, you have to stay very, very focused and organized. Okay? All right. Also, remember that the rows and columns give you the dimensions of the matrix. It's rows and then columns. And the dimensions of a matrix change a little bit about the way you solve it. Not much, it just means you have fewer steps or more steps depending on how big the matrix you're going to have. Now, you can use the information here to find specific elements in a matrix by simply counting. Okay? Just count the rows, count the columns, see what they want. So if they want the element in row 2, column 5, then you go to row 2 and then count over 5 to find it, yeah? So make sure you remember that you can find just about anything by knowing these pieces of the matrix. Now, we need to talk a little bit about what we're going to be working with. Remember that these systems are systems of equations. And the beauty of an equation is that you can do anything that you want as long as you do it equally. So don't think that you can multiply one of the terms by 2. That's not good enough. You can multiply one of the terms by 2, but whatever you do to one of them, you must do to all. So, and you're going to use that a lot. That's do to all, by the way. So, for example, I can multiply one term of an equation by 5, as long as I multiply every other term of the equation by 5. I can even add two equations together and get a totally new equation. And that's perfectly legal as long as you line up the like terms. So whatever you do, you have to do it equally. Okay? Another critical thing that we need to talk about are opposites. Now I'm going to spend a little bit of time here talking about opposites, because it's if you don't understand how to do opposites, then you're not going to understand anything else we do from this point forward. When you're talking about opposites, you're talking about same number, different signs. Okay? So, for example, -2 is the opposite of +2. And we always say negative, but really that is read as the opposite of 2. So literally that minus means that you have the opposite of something. So let's look at finding some opposites. So say we have 4. What is the opposite of +4? -4, right? And all you needed to do to find the opposite of that particular number was change the sign. But say we have something like 5 and 2. Now we want to have two numbers here, and I want to find out what the opposite is, thinking of both numbers at the same time. Okay? So in other words, let's say we start off with 5. Is is 2 the opposite of 5? No, they're obviously not opposites, right? So they're not opposites. But we can change one or both to get opposites. just thinking about the fact that they have to be the same number, and one of them has to be positive and the other has to be negative. So we need to turn them into the same number, and we have to have one positive, one negative. It makes no difference which one's which. Just make sure that you get one positive and one negative. Okay? So let's look at that particular example. Say we have 5 and 2. They're not opposites right now. But is there any number that I can turn a 5 and a 2 into easily? Sure. I can change them both into 10. Right? So I would get 10 and 10. But they're still not opposites. What I also need to do is change the signs. But not signs plural. We only want to change the sign of one of them. So who cares? Let's change the sign at the top. And now we have opposites. Now we need to formalize that a little bit. Think about, what did I do to that 5 to turn it into negative 10? What I really did was multiply the 5 by negative 2. What did I do to the 2 to turn it into a positive 10? I multiplied it by positive 5. And that's what gave me my opposites. Okay? Sometimes you only need to multiply one of them by something. Now, I can't turn an 8 into a 4, but I can turn a 4 into an 8, right? So let's leave 8 alone. But I can turn a 4 into an 8 by multiplying it by 2. But that's not good enough. Oops, sorry. It usually makes 8 if you multiply that. Okay? But that's not good enough because the signs are not right. So what I need to do is, instead of multiplying by positive 2, I need to multiply by negative 2. And that will give me my opposites. Now, if you're lazy, or, I hate to say that, or you just are a little confused, you can always get opposites by multiplying them together and then changing the signs. Just remember, though, that whatever you multiply one part of an equation by, you have to multiply the entire thing. Now look what happens when we add them together. Negative 10 and 10 make 0. 0. 8 minus 8 makes 0. And that's the whole point. What we're trying to do is we're trying to eliminate terms. And to eliminate terms, that means to turn them into zeros. Because if you have 0 of something, that means you have none of them, right? So it's eliminated. Okay? So anytime you add opposites, you get zeros. So let's go to the homework and talk a little bit about some of the problems, just so that you can see some of the things that they're going to do. Then we're going to walk through the stages or steps for working with matrix solutions. Then on part 2 of the video that you're going to see the actual examples. It's not a terrible thing that it actually happened, because now you can go straight to some examples from these, because at first we're going to be doing a little bit of I hate to call it busy work, but just a little bit of practice in specific pieces. Then we're going to put all those pieces together. Okay, so let's go to the homework. Completed problems. Just go to question 1. And it's just asking you, how many rows and columns does the matrix have, and what is its dimensions? Remember, rows are the things that are going from side to side, right? So there are the rows. We have 1, 2, 3 rows, right? And then if you count them out, 1, 2, 3, 4, 5, 6, 7 columns. So that makes this a 3 by 7 system. Now I've already worked these, and so it's giving you the answers, but that's okay because this is just review. Okay? Now, let's go to the next one. Okay. What is the element in the second row, first column of the matrix? So just looking at the matrix, we're talking about the second row, so that's this. So second row, this thing, right? That's row 2. And the first column, well, column 1 is right there. So the number in that position is 0. So you'll see that we typed that in as just 0. Okay, so just practicing seeing where things are, identifying where things are. Okay, now let's do a similar question on this one so that we can really answer the question. It says, by what number must the first row of the augmented matrix be multiplied so that when it's added to the second row, the element in the second row, first column, becomes 0? All right, so I want, in other words, to add these two things together and get a 0. Well, in other words, I need opposites. So right now I have -3 and 9. What do I have to multiply -3 by to get the opposite of +9? Well, it's already negative, so that's good. So all I have to do is multiply it times 3 to give me a -9. Then, if you add those two things together, you'll get the 0 they want. So in other words, it's a very convoluted way of saying, what would I multiply by to get opposites in that first column? Okay, so to multiply those numbers to get your opposites, you'd have to just simply multiply by 3. Okay, make sure you're paying close attention to which position they want you to eliminate. They want you to do the opposites by. Here's another one, just the same like that. Let's just do similar questions so that we can get different answers. By what number must the first row of the matrix be multiplied by so that it's added to the second row, the element in the second row, first column, becomes 0? Okay, so again, we're talking about getting opposites right there. Well, our numbers are 3 and -9. I've already got positive and negative, so I'm good with that. So I'm going to keep the -9. So I've got to turn this 3 into a +9 by multiplying it by 3, which gives me 9 minus 9, which is 0. Okay? So you're just trying to figure out, how can I make them opposites? Just figure out which numbers they're talking about and how can I make them opposites. Now, both of those turned out to be 3s. That is very unusual. Just happened to be because of the questions that they gave you. All right. So now what we're going to do is we're going to look at actually doing some operations on some rows. Use the specified row transformation. Transformation just means you're going to be changing it, right? To change the matrix. They want us to take -4 times row 1. So -4 times row 1, and then add that, do that first, add that to row 2. Okay? So, looking at our original matrix, remember, this one is row 1, this one is row 2. So we're going to take row 1, which is 3, 4, and we're going to multiply that whole thing by -4. That's just a random mark there. Now remember, you can't multiply one thing by -4. We have to multiply them both by -4. So that's going to give us -12 and -16. And then it says add row 2 to that. And row 2 is +12 and +2. You don't have to put the pluses in there. I make lots of sign errors, so I do. You don't have to. 12 minus 12 gives us 0. -16 plus 2 gives us -14. And those are the new numbers that are going to go into row 2. Okay, you'll see that row 1 didn't change, but we've got 2 new spaces to put two new numbers for row 2. So let's plug those in. It's 0 and -14. And make sure that my arithmetic is correct. 0 and -14. There we go. Okay. Now, 6 times row 1 added to row 2. So we're just going to multiply everything in row 6, then add it to row 2, and put those new numbers there. That's all on you. Write the augmented matrix for the following systems. So just make sure that when you're writing the matrix that you put in all of the coefficients. So I'm just going to put the first ones in, and then you can finish the second ones yourself. But all you want are the numbers, but you make sure you put in those signs as well. So the top first will be -3, then +5, and then it equals 2. Remember that line is the equal symbol, so that's where after the equal symbol. So the bottom would just be 9, 2, 6. What the heck? I'll just go ahead and finish it. 9, 2, 6. Right? Making sure they're in the right positions. And watch those signs. I can't tell you how many times. Everything else has been perfect, but I see that students make sign errors. Now, if you look at this one, it's a little different because there are more places, because there are more variables. There's an X and a Y, and some of them have a Z in it. So this is a really important one to take a look at, because if you don't have a number, then that's where those zeros come into play. So it's an X, Y, Z, and then equals. So we have an X, we have 2 X's, so 2 goes there. Then we have 3 Y's, but we have no Z's, and it equals 6. Go to the next one. We have -4 X's. We have no Y's, but we have 6 Z's, and it equals 3. Going to the bottom, we have no X's, but we have -7 Y's, 3 Z's, and it equals 4. Okay? So don't forget, if you have none of something, then it has to be a 0. Now when you look at the next one here, X's and Y's, so you're just going to put it in, and they want to know what size it is. It has 2 rows, 3 columns, so it's a 2 by 3. Okay? Now, when you look at this one, there's something wrong with this one in the beginning. And that is that things aren't lined up. It's 7x minus y plus 4z plus 3 equals 0. Well, that ain't the way things work. Our x's, y's, and z's should be on one side, but that 3 needs to be on the other side of the equal symbol so that we can put it in the right place in our augmented matrix. So what I'll do is I'll simply subtract 3 from both sides, and that will put it in the right format. Remember, it's x's, y's, z's, equal symbol, then the number. Now I can type in the right format. And if you look at all of these, every one of these numbers is in the wrong spot. They all need to move across the equal symbol by doing the opposite. So if it's positive, subtract it. If it's negative, add it. Okay? And also be careful, very careful that everything is lined up. It's x, y, z equals a number. It's got to be in that format or you cannot do the problem. Okay? Let's see what's next. Now they just want you to do it backwards. So in other words, put the x's and y's back in. And you'll look at, there's the answer there, and look at the second one. It's 0 x's, so they didn't write any x's, right? So if I was writing this though, I would go ahead and write them all out, and then go back and erase what I don't need. So it's 4 x's plus 2 y's, excuse me, because you've got to have the pluses and minuses back in, equals 3. Then it's 0 x's plus 2 y's plus 5 equals 18. Oops, sorry, I'm leaving off my z's for some reason. Okay? And then finally, it's -1x plus 3 y's plus 5 z's equals 13. But they are never going to put 0 x's, and they're not going to start with plus 2. They're going to just put 2 there. And also, they're not going to put -1x, they're just going to put 1x. They're also not going to put +1z, they're just going to put z. Okay? So we may need to clean it up a little bit just to be sure, and then you'll see your completed answer which one that's going to be. All right? Okay. Obviously, there's a choice, and I've already made that choice for us because I've already done this problem before. Okay. Let's see. Number 12. Now is where they're going to start using the Gauss-Jordan method to solve the system of equations. So we're going to talk about what that method looks like, and then the examples for this one and as you go forward are actually in the next video. So let's talk about what it's supposed to look like and what's supposed to happen as we go. Once you have these, you can have either a 2x3 or a 3x4. Those are the ones we're going to be solving. Now we only have one of those because they're very quick and easy. We have two of those. They take a little longer, but you're using the same process. And there's a process for making all of these work. Okay? And here's the first thing. First thing you want to do is name the rows. That's not true. First thing you want to do is build your matrix, isn't it? So let's go back to that. First thing you want to do is build the matrix. Make sure everything's in order. If you don't have any x's, then you put 0 there. You know, be careful with it. Think about the things that we just did in that last section. Second, name the rows. If you don't name the rows, then I'm done with you because there's no point. Okay? If you don't stay organized, then when you're working with these, then you're going to make mistakes. As a matter of fact, you're going to see the third matrix. I made a sign error somewhere and it got the wrong answers, which I didn't correct. You all have to do it for yourselves. But you got to be super careful when you're working with these. It's the arithmetic that's going to kill you here. But before the arithmetic can even kill you, organization will kill you. So make sure you name the rows and stay focused. Okay? And here's what we're going to do as we go through them. Now I'm going to show you the process for the bigger one, but the process for the smaller one is the same. You just don't have as much to work on. There are just fewer of them, and you'll see as I said, you'll see the examples. So the third thing is start the row transformations or operations. And it's really easy if you think about it numerically and visually. So that's the way I'm going to give you. Okay? So, first, you're working with the first matrix, right? Because it's the first one you built. You're going to use row 1. To create a new row 2 and new row 3. Okay? So in other words, you're going to have a matrix. And this is the first one you built. So that's matrix number 1, right? And you're going to build a new matrix, matrix number 2. So we have row 1, we have row 2, and we have row 3. These are our original matrix. Okay? Now, this one, we'll just put A, B, C, D for letters here. Who cares? Now, those are going to be numbers, right? They're not going to be letters. They're going to be numbers. Since this is the first matrix, we're going to use the first row, and we're going to be eliminating these two pieces right there. So that means that row 1 is going to come over here and be completely unchanged. Now you're going to use it to change the others. And what's going to happen is you're going to get a new row 2 and you're going to get a new row 3. And the way they're going to look is you're going to have a 0. You'll still have two numbers there. Now I'm going to use the same letters to represent them, but they won't be the same letters, the same numbers. They'll be different letter numbers. Okay? But do you see the big deal is that I got 2 zeros right there, and that row 1 did not change. Okay? Now, that gives you your second matrix. So now we're ready for the second thing, the second matrix and its operations. Okay, so let's go to another page. B, for the second matrix. Well, if you're in the second matrix, what do you think you're going to be using? The second row, right? Now remember, we still have row 1, which is A, B, C, D. We have a new row 2 and a new row 3. Well, that one was 0, 0, D, E, F, G, H, I, J, K, L. This is going to be harder for me in a minute. I'm going to have to remember the alphabet too. Alright, so it's the second matrix we're working on, right? So that means we're going to be using the second row, and we're going to be working in the second column. And so what it's going to look like once we do our row operations, and you're going to see examples of these, trust me. Alright, this one is not going to change because that's the one we're using. The one that we're using is not going to change ever. It just slides right over into the next matrix, right? And remember, this is matrix 2, and we're building matrix 3. Now, we are going to get a new row 1, and what's going to happen is it's going to have a 0 there. And we are going to get what we're going to call final row 3. Not new row 3, because we already did that. Final row 3, which is good news, because final row 3 means it's over. And so it's already going to have a 0 there. We're going to get a 0 there. And so it just has numbers there and there. Okay? So that's what matrix 3 looks like. Okay? Now, if this is matrix 3, what do you think I'm going to use? I'm going to use row 3, and I'm going to be working in column 3. Okay? And here's what that's going to look like once you do your operations. I'm just going to write it here. We're going to get a final row 1, final row 2, and we already had final row 3. And here's what the matrix is going to look like. You'll have a number there, then 2 zeros. You'll have a 0 and a number and a 0. You'll have a 0, and a number, or a line, and then you're going to still have numbers there always. So what's happened is you end up with this diagonal of numbers, and everything else is zeros. Now, of course, your answers across your equal symbol are still going to be numbers. So all we have to do is then solve these equations, remembering that this is where the x is, so that's ax. This is your y, that's your z. So you solve the top one for for x, and then etc. So it's ax, fy, kz. So divide by a, divide by f, divide by k. They're just 3 linear equations. And when you get the answers, you're simply going to put them in the form x, y, z, enclosed in parentheses, because these answers represent points on a line. Okay? So your big thing here to remember, to stay focused, okay? Got to use opposites, so that means that you're going to get opposites to make zeros, and again, you'll see those in the examples. And if you're working in matrix 1, you're using, if it's in the first matrix, you're using row 1, and you're working in column 1. If you're working in matrix 2, you're using the new row 2 and column 2, right? So 3, 3, and 3. Circle. Use different colors if you can. Makes your life a lot easier. But you're not done unless you get that diagonal of numbers. And then it's just a matter of putting the x, y's, and z's back in so that you can solve the equations. Super simple. Now you can use the process the way they do it with Help Me Solve This and View an Example or the videos. They use a million fractions, which is a nightmare. If you do it this way with this method, you do not have to have any fractions. Now technically, is it Gauss-Jordan? It's still the same process. You still get the zeros. You just don't get the ones until the very end. Well, I don't see any reason why that's different. So, sue me. Okay, watch the second video to look at the examples. And that's the last lesson that we have before our final exam in this course. Thanks, guys.